Hello all. We're going to give it a couple more minutes or a minute or two to let a few more folks in, as we do have a bunch streaming in. But thank you for joining us today. Okay, we can start. Hello all, thank you for joining us for our latest installment of our Thought Leader Series webinar. This one is Insights into Metering and Measuring Heat Pump Performance, and it's presented by Nelson DiBiase, and I'll say Nelson DiBiase and friends, as he has a couple of folks with him today to also add to the presentation. I'm your host, Sean Kelly. I am the Director of Sales Operations. Looking at the attendee list, I do see a few familiar folks from over the years. I oversee our sales operations group, inside sales group, and customer service group. I've been with Onset for 13 years in various positions, and one of those was account development manager specializing in our indoor environmental market, which is where I met our presenter just a few years ago. So some details about the webinar. It'll run for approximately 45 minutes, and the last 15 minutes or an additional 15 minutes will be to answer questions at the end. For your questions, you can type those over into the questions section on your control pane, and the webinar is being recorded, so we'll be sending a link out to anyone who had filled out the form. Also, please, go out to our YouTube channel and like and subscribe any of our webinars that we have out there as well. All right, who are we? HOBO, we make data loggers. That's what we do. They're low cost, highly accurate recording devices, various measurements. We're located in Cape Cod, Massachusetts. And again, our focus is accurate and reliable data loggers. We are a world leader in loggers with a global network of distributors. We're ISO certified, and we were founded 43 years ago. So we've been in business for quite some time. Today's presenter is Nelson DiBiase. He's the managing consultant in the energy, sustainability, and infrastructure segment at Guidehouse. He co-leads the field operations team and oversees and advises on-site metering and verification studies. And he has a dual background in business administration and sustainability, and he's committed to driving positive change in the energy sector. With that, I would like to present Nelson DiBiase to you.
Thanks for the more introduction, Sean. It's been a pleasure to work with you in Onset / HOBO over the past couple of years. Y'all have been a key asset to allowing us to meet our tight field deadlines, anywhere from scoping out projects to ordering equipment, and to being live in the field with loggers. So thank you for that. Also, I wanted to let folks know we have Daniel Ferrante on this call as well. Dan's a managing consultant here at Guidehouse, who is the field manager for the project that we'll be presenting on today. So Dan will help address any questions that pop up throughout the webinar. And as Sean mentioned today, I'll be presenting on metering heat pump performance as part of Onset's Thought Leadership Webinar Series. And before we dive into it, just wanted to start off with a poll to see, what brought individuals here today. So if folks could, respond accordingly to the poll that I just launched. Give it a couple minutes for answers to fall in. See a lot of interest in the performance of heat pumps. Some interested in different end use cases for HOBO loggers. A couple of folks excited for electrification. All right, great. Well, yeah, it seems like the majority of folks are interested in performance of heat pumps, so that, you know, right on par with for the presentation. So for today's agenda, first we'll dive into the heat pump metering study that was conducted over the past 2 years in Massachusetts and Connecticut. We'll then look into the design and implementation of the metered portion of the study. We'll then take a look into how we collected the data on site using on-site equipment, and then followed up by some key findings from the study, and then looking in lastly into some data logging challenges and opportunities that came out of this study. Before we dive into the presentation, though, I do want to call out a couple, key terms and abbreviations. So HPMS will stand for Heat Pump Metering Study. That'll be the focus on today's presentation. I put a link in it here. Onset may send this out to afterwards for the full report of the study. And just want to let folks know that there will be an updated version of this coming out this month with additional metering data. MSHP will stand for mini split heat pump, CHP for central heat pump. Full displacement will be, meaning a heat pump installed with the intent to fully replace home's pre-existing heating system, versus a partial displacement will be a heat pump installed with the intent to partially replace the pre-existing heating system. Backup system is anything such as a boiler, furnace, wood stove, anything that's backup to the heat pump. And COP will be referring to the coefficient of performance. So essentially the ratio of heating or cooling provided to energy required. Higher COPs equate to higher efficiency. In situ will mean AKA on site, in this case, the meter condition. So what we collected while on site. So looking into the heat pump metering study, the main study objectives included for residential heat pumps. We're trying to assess the heating and cooling performance and usage of those, and in addition to estimating baseline HVAC consumption across all fuel categories, so delivered fuels, electric, gas, and finally trying to quantify gross baselines to drive gross measured impacts that would then later be implemented into utility technical reference manuals, otherwise known as TRMs. And so when we look into the scope of the study, it involved Massachusetts and Connecticut residential customers that either had the partial or full displacement of their heating systems with either a central ground source and or mini split heat pump. The main research topics from the study mostly focused on performance, so including cold air performance, operational COP, and seasonal performance. Usage to help identify overall measure impacts and fuel savings. And then also identifying specific usage patterns for partial and full displacement sites, including switchover temperatures, operational patterns, control sequencing, and ability for systems to meet a home's load. Also, we looked at gross baselines, so what is the distribution across different system types? And finally, customer experience with the heat pumps. How satisfied were these customers with their heat pumps? What were the main pain points? What are the main drivers for them to switch over to these heat pumps? And a lot of that was carried out through survey work. So when we look at in order to address these research topics, our team conducted surveys and collected on-site data. As you can probably imagine, today's presentation will be largely focused on that metered portion of the study. However, it's important to note the survey part for it, kind of feeds the folks interested in the actual on-site metering. So if you'd like, additional information kind of on the surveying, you can look at the full report with that link I sent you. You also be able to dig further into the analysis. So on a timeline, you can see that we started the study in fall 2022 and started with the Wave 1 survey. The survey asked a lot of those, what are the key motivators for switching over to the heat pumps, and all of that. At the end of the survey, it would ask the folks if they'd be interested in participating in an on-site metered portion of the study. And from there, our field team, who is Ridgeline Energy Analytics, had a decent amount of folks to recruit from for the Wave 1 installs. So that started all the way back in fall of 2022. I'm sure Sean remembers a lot of those early conversations. And from that, we had some revisits. It was like kind of the start of the study. So we're going back, putting loggers back online, doing additional testing. We also had some fast feedback interviews after different cold snaps that occurred throughout the winter 2023. And as you can see, this process repeated again for the wave 2 sample, which started in spring 2023. And same thing, we had the survey that then fulfilled the on-site metering portion. And in total, we had 101 sites with on-site metering in Massachusetts and 84 sites installed in Connecticut as well. The sample design and representativeness is further discussed in the report, but at a high level included different variables, including single family and multifamily buildings. It's also broken up between different system types, so mini split heat pump, central heat pump, ground source, and then also displacement scenarios, the full versus the partial displacement. Throughout the waves, we, as I mentioned, conducted other fast feedback interviews to capture customer feedback during cold snaps, as well as conducting various revisits to ensure alert loggers were online and we weren't losing any data. The study then recently concluded this summer. And the team conducted an end of season survey and uninstalled all of the equipment. So that's just kind of like a high level methodology, but also the timeline for the study. So next we'll be discussing how we actually collected a lot of this data. So if we look at a central heat pump performance site, it's kind of illustrated with the icon on your left. You can see that we installed MX equipment at the outdoor air compressor and within the air handler for performance sites. So the air handler being, in this case, in the attic, and outdoor compressor on the left side of the house there. We also installed at the electrical panel an E-gauge. And so the E-gauge was installed within the panel to capture any usage data for the heat pump, but also for any backup equipment. So in the schematic, you can see we have the electric resistance heater. This could be really anything that had a designated circuit within the home that could be used for backup heating. We would measure that at the electric panel as well as like the mains using current transformers, and a lot of the E-gauges connect via Wi-Fi. So we're able to see that data live time. In addition to that, if there's something, a backup space heater or a window AC unit in this example, we'd also meter that with the HOBO plug load meter, which we'd then download later, but it has like a year's worth of data on the plug load logger. And similarly, to a mini split heat pump site, performance site, we'd meter the outdoor compressor with the MX line, but we'd also be capturing the fan current speed for each indoor mini split head at the outdoor compressor. We'd also then install meters on the indoor mini split heat pump heads. So, if there are multiple heads, each one of those would have loggers on them, and I'll kind of dive into what that specifically looked like in the next couple of slides. But likewise, we'd still capture everything at the electrical panel. The one, thing that's different in this site is it has a backup gas or oil boiler. So in those scenarios, we would still use an, MX temperature probe on the boiler flue, or if it were a furnace, it would be on that flue as well. And then we would have the copper loggers and smart oil gauges, copper loggers syncing up to the AMR gas logger frequency, and then the smart oil gauges using ultrasonic sensors to detect, how much fuel oil is left in the tank. So with the on-off from the temp probe sensor on the flue, and with the minute consumption from either the copper logger or the smart oil gauge, we're able to see how much that boiler was consuming and how much it was putting out into the home for heating. And also please know, this is, these both illustrate performance sites. The study also included sites that were capturing usage only. So we want to have the MX equipment, on the indoor head or in the air handler. And additionally, for all the sites, performance sites, there are also spot measurements that were used to capture. So, we're doing a lot of airflow testing using bolometers and flow hoods, and I'll kind of show you some of those photos in the next couple of slides. So if we zoom in and take a look at the metering at the heat pumps specifically, we can kind of highlight the use of the MX line of loggers. So as I mentioned, the power for the heat pump or the air handling unit was captured at the panel on the E-gauge. But the fan amperage, that's where we used the MX1105 plus 1 amp current transformers with a custom inverter on it to get each mini split heat pump head fan current. And then for the outdoor temperature for mini split, if we had an extra slot available, we would throw in the MX1105 temperature probe, or we would put in an MX2304, which is just their outdoor rated temp probe sensor on the outdoor unit. And then for the indoor supply and return temperatures and humidity, that's where we use the MX2302As. So for central heat pumps, we would utilize these loggers, one in the return area and one in the supply ducts. And for that, we would just drill a hole in, cover it up with tin foil tape and go from there. For mini split heat pumps, it was a little more complicated. We'd collect the supply air temperature and then place 2 sensors on the air outlet to account for the variability of temperature outputted across the mini split grill. So that is actually 3 MX2302As per mini split heat pump head. So I'm sure you can imagine, a house that has 2 mini splits with 3 heads each, it's a lot of loggers in the house, but there's a lot of variability across the states and then also the different strata. So, but that's kind of how we kind of captured performance on the site level. So here's some actual photos of the installations. So the photo on the left, that's one of the MX1105s on an outdoor mini split heat pump. We put it in a weatherproof box because a lot of these loggers were, out there for over a year, going through the New England winter, and we didn't want snow or rain to get into it. So put them in these weatherproof boxes. You can see this mini split had 2 indoor heads because there are 2 of those current transformers being plugged into the MX1105. So that's kind of a photo of the install at one of our pilot sites. The middle photo is of our field technicians, Ridgeline Energy Analytics. This was early on. I know Dan Ferrante is on the call. He was there, David Korn from Ridgeline and his whole team. We're all at a friendly Guidehouse site and testing out these different loggers. And Sean, I think you were probably also on speed dial during this time. So just installing these loggers, figuring out how best practice and what the data looked like coming into them. The photo on the right is a photo of the E-gauge installed at the panel with current transformers to capture heat pump usage. I think this photo is actually for the same site, so you can see we're capturing, it's kind of difficult to tell, but we're measuring the energy consumption for the heat pump, but then I think also a water heater just to get some additional data at the pilot site. So moving on to some of the MX2302A metering. The photo on the far left is an example of how a mini split heat pump, how we're measuring across the supply duct. So in the photo, I don't know if any of you folks have used the MX2302As, but it does not look like that white, the white logger. That's actually, we were testing a couple different loggers for this study, and this was a photo from one of the pilot sites. And we ended up going with the MX line just because of the backup data and Bluetooth connectivity. But that's essentially how we would install it: one on the far left end and one on the far right end, and then one on the top for the supply. And then the 2 photos on the right are kind of illustrating how we would install those loggers for an air handler. So one on the return and one on the supply. A lot of times this would, a lot of these ducts were insulated and it was kind of difficult to get into, but at the end of the day, we were able to patch up those holes pretty easily. And then also here's some photos of the airflow testing. On the far left, you have barometer readings for a central heat pump. In the center, we have a photo of, we did a blower door test at some of the pilot sites. And then also we have flow hood readings from a mini split heat pump, one of the indoor heads here. And all of that, went into calculating COP, which I'll cover in the next slide. So the methodology for calculating the COP, so after we would collect all this 1-minute interval data from all these different loggers, we averaged out the data across a 5-minute period to help reduce the noise. as I'm sure you can imagine, with 186 sites and a lot of variability in the homes and loggers and connectivity, there's definitely a lot of data noise. So we average it out to 5-minute periods. And then from those data points, the heat delivered by the heat pump was estimated by standard enthalpy calculations, and following the supply and return air temperatures and relative humidity, as well as the airflow that I just showed photos of with the bolometer, and was estimated as a function of fan amperage and measured fan curves. And for any site that was a mini split heat pump, the data was summed across the indoor heads where appropriate. So from that average data and from those data points, the COP was calculated as the ratio of heat delivered and the energy used by the heat pump. So that's kind of, the COP was kind of the largest calculation, I think, in measuring the performance. A lot of the usage data came directly from the E-gauge, and that's kind of shown here as well in the raw data at the very bottom, the kilowatt used by heat pump and air handling unit. That was all captured via the E-gauge and feed directly into some of the usage data and some of the information we pulled from that. So next we'll kind of look into some of the key findings from the study. And as I mentioned, I'm going to kind of focus on the metered portion of the data. There are tons of more findings in the full report if folks would like to take a deeper look into that. And some really interesting findings from the surveys as well. So definitely recommend taking a look at that after this webinar. So for heating, the average heating performance values were comparable to new heating seasonal performance factor rated values. And as we expected, the COP for central heat pumps and mini split heat pumps decreased as outdoor air temperatures decreased, trending towards a COP of 1.5 to 2.0 from 0 to -10 degrees Fahrenheit, whereas the ground source heat pump showed a consistent COP across the heating season at approximately 3.0. On the other hand, cooling, the average cooling season SEER values were lower than rated SEER 2 values. And just for everyone's awareness, higher SEER values indicate a higher level of efficiency. And then if we take a look kind of at the use of backup systems, and this is kind of what I was discussing with some of the gas proxy data from copper loggers or smart oil gauges, and also customer surveys, but heat pumps met a large majority of the heating and full displacement applications, roughly 86 to 99% of the heating load, and for partial displacement sites, roughly 65 to 79% of the heating load. A few participants did indicate that their heat pump was unable to keep them comfortable during the lowest outdoor temperatures. I don't know if folks remember that cold snap back in winter of 2023, but it was pretty brutal here in Massachusetts and Connecticut. And these participants noted, potential system undersizing or wishing that they'd installed a cold climate heat pump. And a lot of this data was the data captured from this fast feedback surveys. So some really good qualitative data there. And then most of the full displacement customers that did end up using the backup heating, noted cost considerations. So, electric cost was relatively high to other fuel costs, especially if folks had, leftover oil in their oil boiler. They may want to use that up in the wintertime. And also performance for using another system or fuel. A lot of folks like the coziness of using a wood stove for heating, or or a pellet stove or something of the sort. So just some customer preference types there. And then also oftentimes, portion of the home may not be served by the heat pump. Maybe it's one of their kids' rooms who's away at college that comes back home just for Christmas. They turn on that electric resistance heater or something in their bedroom. So there's some variability in kind of the use of backup systems and how these homes all met their load. And I think that's kind of sheds light into the importance of having a representative sample, and also kind of having that high 186 performance sites, or 186 sites total, all getting usage data is really important. And then if we look at heat pump usage, a lot of the variability, as I kind of touched on, is just customer preference, turning off and on the units, use of backup systems, use of integrated controls, and switchover temperatures often varied That probably just be from whoever installed it and set those temperatures is kind of what, swayed it, and obviously is going to differ from region to region, to installer to installer. So yeah, there's a lot of variability, but a lot of it was just from consumer end use. And then customer experience. Most customers were very satisfied with the cost of operating their heat pump, although 29% of participants claimed that the higher energy costs impacted how they ran their heat pumps. Right, so that's kind of that whole idea of, okay, maybe they turn on more space heaters or their wood stove just because of that cost of electricity and cost of keeping their home warm. There was minimal maintenance issue across the 2 to 3 year installed period. The highest we saw was for mini split heat pumps at 19% had maintenance issues, only 9% for central heat pump, and 1% or less than 1% for ground source heat pumps. So definitely highest for mini split, lowest for central, and lowest for ground source. And most respondents said that their heat pumps did keep them warm during the winter. 93% of full displacement customers were satisfied, and 86% of partially displaced customers were satisfied with their heat pumps. So lastly, we'll kind of look into some of the data logging challenges and opportunities. But first, just want to note, and Sean can potentially correct me here, but we were probably one of the earlier adopters of the MX line of equipment, at least to this scale. But luckily we had great contacts, including Sean and his R&D team at Onset throughout the study. So we were definitely providing live time feedback for the systems, and a lot of the challenges that we faced are probably already being addressed or already looked into because of some of that feedback we provided. So thanks, Sean, for keeping that line of communication open. And I don't know if you have anything else to add there, Sean. But
yeah, absolutely. I think what you saw back in the initial install was using our dashboards on HOBOLink, and there was a delay there. I think it's gotten better over time in populating on that dashboard, and we're actually releasing a new HOBOLink 2.0, which should only make things better moving forward.
Yeah, so to Sean's point, I think some of the challenges we faced, and this isn't just exclusive to the MX line. This was also for we had a lot of other Wi-Fi connected devices. But, connectivity with a lot of these loggers was difficult. For 186 different sites, each home is going to be different. We're trying to get a representative sample of installed sites. So connectivity was patchy, especially when trying to grab data loggers. Some were inside and outside. A lot of these loggers, for instance, like the MX1105 was in a weatherproof box, in front of a heat pump. So it has to, Bluetooth would have to go around the metal of the heat pump, and oftentimes would block that signal. So luckily, though, a lot of the onboard storage for the MX1105s was sufficient to kind of capture it whenever devices did go offline. But on that similar thread, onboard storage, loggers with onboard storage are often not robust enough to capture the 1 minute data for a full year. Once again, not really inclusive of the MX1105s, but more so inclusive of the MX2302As. Those, luckily we had a lot of, different mini split. For instance, on the mini split, we would have 2 of the supply temperatures. So we were, sometimes able to use that backup data. But unlike the MX1105, we maybe have to revisit those sites to get them back online. It could just be from a participant accidentally unplugging the gateway, or it's ample opportunities, I guess, to kind of get those things offline. But onboard storage was definitely a struggle, and that was also representative in some of the other loggers too. For instance, smart oil gauges and copper loggers don't have any backup storage, but E-gauge we're pretty comfortable with, and it would store a year's worth of data at least. So, and then next one is kind of battery. Bluetooth enabling, obviously would require a little more battery life. And so, when the study kind of, gets extended and continues over a year, which I think is the I think it's the estimated battery life for an MX2302A with Bluetooth enabled is roughly a year. So it's definitely, just trying to address that and see what loggers are, struggling with battery. And all of our loggers did require to have Bluetooth on just so we could see that data live time and, collect it and clean it as we went through the study. And then, kind of what Sean mentioned for HOBO Link, delays in HOBO Link showing what loggers are online. Sounds like HOBO already has the, Connect 2.0 coming up soon. So, this is probably just not even applicable anymore, but, just some challenges that we faced while we're on site, and, a lot of other, logging apps, also have some of these challenges too. So, but as far as, opportunities, a lot of these systems, and Dan Ferrante is kind of the brains behind a lot of this, but a lot of these systems, do have these onboard sensors and, already kind of capturing this data that we're looking for. But it's kind of a gap to actually for, someone like Guidehouse to kind of utilize that data and capture it for logging purposes. So it'd be really cool if there, were a way to kind of tap into those sensors and kind of collect that data just from what's already built into the systems themselves. But that's could be further down the pipeline. You never know. Yeah, and now I guess I kind of open up the floor to any questions that folks have. Now we're at the 30-minute mark. So I see one. Will the full report be supplied to the attendees? Sean, I guess, do you want to take that one?
Yeah, I answered that one privately, but yeah, it's I think we can include the link with the follow-up email where you'll have a link to the presentation. You'll also have a link to that report as well. We can add that.
Awesome. And Dan, were there any questions that you're unable to answer via chat?
I can see a couple here. Dan Mort wanted to know a little bit more about the copper loggers.
Yeah, so the copper loggers, they kind of capture if your gas meter at your home is a type 12 meter, so that's pretty much puts out the radio frequency for gas companies to collect, how much you're consuming versus them coming up to your doorstep to read the meter. So it's kind of like a newer type of gas meter. If it's the type 12 meter, the copper logger, what it does is it picks up that radio frequency and then syncs it to this little device that's plugged into your wall inside, and then we can capture that minute interval data consumption of your gas usage.
Okay, we have another one that says, how do you account for the temperature distribution across the supply airflow?
Oh, that's a good question. Dan Ferrante, do you want to take that one? I don't know if Dan is online or not. He's still on.
We can always get back.
Yeah, we can always get back to you on that one.
We'll address it.
Yeah.
All right. Was the measured COP compared to the theoretical or MFCR performance curves of the heat pump?
So it's compared to the performance curves of the heat pump. And actually, I just found Sean the question pop up, so I can see it now too.
Okay, you can see him. All right.
Yeah. How critical was the sample intervals used in calculating the COPs? I mean, I guess it's kind of in reference to, averaging out the minute data to reduce noise. And I think, averaging out the data into the 5-minute intervals was kind of just necessary to clean the data. There was a lot of variability when looking at it at the 1 minute interval. So it was definitely critical, like as a whole, to analyze it. Maybe on a site by site basis, you could say, for this site, we'll keep the 1 minute intervals, but for the full report, the 5 minute was critical for cleaning it. And Dan, thinking back to the temperature distribution across the supply airflow for mini split heat pumps, I believe it was just averaged out for the two. We had two loggers on each indoor mini split head. Adam, I see your question on, was there any analysis done to compare the drop in COP versus the building condition, aka how much better does a well-insulated airtight building perform? Yeah, that's a great question. That wasn't in scope for this study. It was kind of like in question in the beginning phases of it. And that was kind of why we were looking at doing the blower door test. I'm sure that question popped up whenever that part was being discussed. I think there's definitely room for, in the future to kind of touch on this. But it wasn't addressed necessarily in this study exactly, relating performance to tightness of the house. Omer, can I please get the details of the sensors and cost, especially the airflow meter with hoods? That's something that we could follow up with afterwards. We also have our contact information on this slide, so maybe I'll just leave this up. I'm answering the remaining of the questions. My contact information is here. Ryan Pawanda was the project manager for this project, and Daniel Ferrante, as mentioned, is the field manager. And I also put in David Korn, his contact information. He kind of led the Ridgeline Energy Analytics field team and helped a lot with kind of the R&D of the loggers in the initial phases. So, and yeah, if David, if you're on the line, yeah, thanks for all your help with R&D for the study. Okay. Early on, we saw some David Corrin. Early on, we saw some recovery when connectivity was poor and the loggers loaded missing data automatically. That feature no longer seems to be available. Is that correct? Sean, I'll let you take that one.
Yeah, so the way, if we're using a logger along with our gateway device, the way that it works is that the gateway takes a sample at the time of the logging interval. So if you're logging every 5 minutes, the gateway will take that measurement and send it to HOBO. So there's no, it doesn't store anything in the gateway. It's if that, it actually sees the Bluetooth packet in the air. And if that Bluetooth packet isn't present, it's not able to grab it. So it won't be on HOBO, but the data is still captured within the logger. Actually, I see one here too, Nelson. It's
the battery one.
Oh, well, the one about, it says, does the MX logger not give the option to sample each 1 minute and average into a 5-minute data recording? It does have statistics logging. So what you would do is you would set, say, a logging interval of 5 minutes, and then you could enable, say, average with your statistics sampling interval of 1 minute, and it would give you the average over that 5-minute interval. And then you also have the option for maximum, minimum as well.
And then Sean, how much does the Bluetooth reduce the battery life for the devices?
Yeah, I looked into that while you were going over it. So the 2302 it's a 2-year battery life with the advertisements at 1 minute. And then when you disable the Bluetooth advertisements, then you'll get 5 years. So the Bluetooth does take up quite a bit of the battery power. So ideally, if you're not in an environment where you're using a gateway, you would use the logger, turn off Bluetooth, and then when you get on site, you'd hit the button, it wakes it back up, and you're able to configure, download, and then configure again if you wanted to. Yeah.
Awesome. Zach, I saw the barometer for the mini split heat pumps. What about for central heat pumps? How did you get the CFM for those? Let me go back to the photos. So as you can see here, this is actually on a central heat pump, the barometer readings from that.
Hey,
So,
Nelson, can you hear me?
Yep, I can hear you, Dan.
Hey, sorry, I was having some audio issues before. To that question, we used a variety of methods, as Nelson was just showing on screen. If there was a central return, we would sometimes use the flow hood for simplicity's sake, but for the majority of sites, we used a flow plate, specifically the true flow, which measures airflow through the system return. There is a little bit of setup. You have to calibrate it using the existing static pressures across the supply and return. But through that, you're able to calculate your airflow. And that was the primary means of calculating airflow for central systems, which we did perform at multiple points. So the majority of these systems have multiple fan speeds. So we performed multi-point airflow testing for both mini split and central systems, so that we could also log the associated fan power at that speed. And then after the fact, once we have all the data, then we can correlate airflow based on the fan power readings from our spot measurements collected in field.
Great. Thanks, Dan. And then I guess, Dan, do you also want to take Charlie's question? Was the measured COP compared to theoretical or manufactured performance curves of the heat pump?
Yeah, this is a great question. So the rated efficiency for, particularly for something like a heat pump, this is based on standard rating conditions. When I say especially for a heat pump, what I mean there is that heat pumps are unique in that the capacity and performance will vary based on ambient air temperature. So I want to distinguish that the primary function of rated efficiency values are so that there is a standard sort of benchmark that all manufacturers can report against, and allows for sort of equitable comparisons to be made throughout industry. It does not necessarily indicate real world performance. In the context of our study, if you did want to try and associate rated values with real world performance, given that we were installing these primarily in Massachusetts, generally the Northeast, it is most appropriate to look at probably your region 5 efficiency values, specifically your HSPF 2. So HSPF 2 and SEER 2 are recent changes to the rating conditions. They've been updated. We won't get into the weeds and all of that, but the region 5 is specific for northern climates, and the rating standards used to generate these efficiency ratings will weight the number of hours at different operating temperatures based on the region. So the actual weather data that was experienced during or throughout the study, it actually falls between region 4 and region 5, and by and large, the efficiency throughout the study was consistent with COPs and subsequent HSPFs, with the focus primarily being on heating, falling between the rated performance values for region 4 and region 5. So that's a long-winded way of saying that they operated primarily as you would expect.
All right, awesome. Thanks for the response, Dan. I know we're also at time. I do know there are some additional questions that I don't think were addressed. So if anyone has any additional questions, feel free to reach out to our team here. I don't know if these slides will be sent out afterwards, but you'll have the contact information there, or take a screenshot now. And then also, like I said, a lot more information on this study is in the full report, which is publicly available. And I think Sean can send that out to everyone who's on the webinar. So anything else, Sean, before we wrap up?
No, I think that's it. I would like to reiterate, we will be sending out an email with a link to the webinar, so you will have it and you can jump on there again and review it. It will also send that link to the report. But thank you so much for doing this. We really appreciate it, Nelson and Dan, and I know I can see David Korn out there too. So thank you, David, for all your help in this as well.
Yeah, thanks all, and thanks Onset.
Yeah, all right, guys. Well, thank you all for listening in and watching. And again, if you do have any questions, obviously you can reach out to Nelson or Dan or David. And if you have any questions about data loggers, I'll be happy to help.
Awesome.
All right.
Thanks all.
Thank you. All right. Bye.